Okay, so this page 353 is found on Google Classroom. I just added it under blank notes to use with topic 4. It says page 353, but it actually goes in front of everything. I got it last year at a workshop, and it was just too good not to use. And it fits in here, so that's why I'm doing it.
You found a singular page?
It's just a singular, yep, front and back.
This one's interesting.
Okay. Well, it was from the same guy who made all this other stuff.
Oh, but
He just added to it, and so he gave it to us. I went to his workshop last year.
Was it a good workshop?
It was fan flipping tastic.
Did you get
How did you do it? How did you go last year? This was made in 2018.
He gave them
Last
the
year
free
was
version.
2009.
Yeah.
He gave them the free version.
Actually, oh, do you know what last year was?
Okay.
Well,
So
that makes sense.
we have been.
It says it's 2018, not 2019.
Well, that doesn't mean just because he shared it with us last year doesn't mean it was brand new to him.
Yeah.
It was just brand new to me.
Brand new.
You okay?
Why is my Wi-Fi channel?
Wait.
Anyway, I'm going on. So up until this point, we have been doing things like this. And everything has been dy dx. But
Yes,
really,
why?
those of you that are taking physics, and you're going to love this, we know that in physics, we have rates, which we have in here as well. And rates are with respect to,
Gravity.
well, okay, think about the gravity. Gravity is, you round it to 10, right? 10 what? What's the unit?
10 meters per second squared.
Meters per second squared.
When?
So on bottom, you have what unit? Seconds.
Weird.
So you're deriving with respect to what? What time?
Oh, we're doing distance and time.
So rates, we're going to be dealing with, most of these are going to be derivatives of whatever with respect to time. So this is going to tie in. We're going to end up doing velocity, and we're going to be doing acceleration, and all these things. Velocity is just a first derivative.
Can I drop?
Acceleration is the second derivative for those of you that are in physics.
Can I drop now?
And then you can use, then you can use the shortcuts. Because now you'll be able to do derivatives.
Why
to figure that out.
Phone teach us we need to do short.
Well, because not everybody has calculus.
But here's the other thing. High five to myself. This is still math physics. This isn't common sense physics, Miss King.
No, you'll be okay. Here we go.
Okay.
So what we're going to do is we're going to write these in calculus notation. So we have the area of a circle is increasing at a rate of 6 square inches per minute.
What kind of circle is that?
So, you have a circle.
It's a ball.
And
You're
it's-
inflating it.
Yeah, it's getting bigger.
It's a balloon.
I was like, that's a curve. Go look
Beach
at
ball.
the
It's a beach ball.
That would be a sphere, actually. So, we're just doing a drawing, and it's expanding. Or you could think about,
a whirlpool.
well,
Somebody's
whirlpool.
laying tiles in a circle.
I was thinking like a crop circle.
Or a whirlpool.
And they keep going out so it's expanding.
Or
Mhm.
a hurricane. Or a whirlpool.
Okay. So the area of a circle, we would write that as dA dt
What?
because it's at a rate. So this is the rate part. Is the derivative of a, because we know derivative is the same thing as a rate. The same thing as the slope of a tangent line. So the area of a circle is increasing. So that means it's going to be positive at a rate of 6 square inches per minute. So 6 inches squared per minute. All right. Volume of a cone is decreasing at a rate of 2 cubic feet per second. So how would I write, since it's a rate,
Question.
dV/dt.
dV/dt? Yes,
I was
ma'am.
gonna ask if the symbols were gonna say the same. I was like,
Well, V stands for volume, T stands for time. So we're taking the derivative of volume with respect to time. So dV/dt equals what?
-2 feet cubed per second.
-2 cubic feet per second. Let's see if you can fill in the next.
my enamel's not okay. And now we're drinking coffee.
Oh. Get you some of the special toothpaste.
I think I already have it.
Oh. Quit eating ice, baby.
That's if you're anemic.
Uh-oh. Do you eat a lot of ice?
Mm-hmm.
Yep.
I do everything that destroys your enamel in like a day.
I can't eat ice.
Oh, it's very entertaining.
Wow. I went to the dentist for the first time in a while. This was probably 10 years ago. And they looked at my teeth and they said, okay, are you bulimic? And I'm like, do I look bulimic? And they just kind of laughed and I was like, what? And I guess because my enamel had done really bad and come to find out I was gritting my teeth really bad.
It's like, aren't the, like, bulimic is not like when you throw up?
Yes.
Okay. That makes more sense. I was trying to put 2 and 2 together.
Yeah. And I was like, I'm so not bulimic.
Well, when I went to the dentist, I wasn't drinking coffee every day.
Okay.
So, I do, in fact, drink a lot of coffee every day.
Okay, so Faith,
Yes.
give me this next one.
I literally just said DH over DT.
Yes, DHDT,
Why?
because it's the height of the tree,
Yes, I got the H part.
and it's at a rate and it per year, so that would be
I'll
time.
go with centimeters, okay.
No,
I didn't
That's
know-
the height.
Yeah, I don't know why I put, I was like, what do I put on?
Equals what, Faith?
3/7 centimeters squared per year.
Except for it's not squared.
Cool.
It just says centimeters per year. You just write down what you see. All right. Lilies, what's the next one?
CA over DT.
Okay. I'm going to write d theta over dt, but yes, you're fine.
I kind of just drew an angle.
Yeah, the reason why I didn't put a is because we can get it confused with